Okay, so this task is a variation of the classic handshakes task, where you have a certain number of people in a room and they each shake hands with each other once, and how many handshakes there are. You can see the context for this question is in a Rugby World Cup pool. You've got five teams in a pool, and they each play each other once. So how many games are there going to be? So it's exactly the same mathematical problem, just that the context has changed. And I'm going to show you now how I might use this in the classroom, and two different manipulatives to A, model the solution to the problem, and then B, show a generalization to the problem. So to model the solution to this problem then, I find it really useful to use a circular geoboard with the number of pins corresponding to how many teams you've got, or how many people you've got in a room shaking hands. So you can see, I've got 5 pins arranged, and then if this first dot here corresponds to the first team, then this team has to play every other team. So 1, 2, 3, 4 games contributed to the total. Now moving round, and we'll go around in a clockwise manner, this second team has already played the first team, so we're not going to add that one, but they still need to play the third, fourth, and the fifth team. So that adds another 3 to the total. Going round again, this third team has already played the first and second, so they just need to play the third and the fourth team. And then the fourth team has already played the first, second, and third, so they just need to play the fourth. And by the time we get round to the fifth team, they're already connected to each of the other teams, so we don't need to add any more to their total. So, what's the total number of games played? Well, it's just a case of adding up the lines now, and you'll see, because we've done it systematically, you spot a nice pattern here. So the first team was 4, then the second team was 3, and then 2, then 1. 4 plus 3 plus 2 plus 1, which is a total of 10 games. So we've got this solution for 5 teams. They play 10 games, but to be honest, I'm not really interested in the answer of 10. I'm more interested in this calculation that we got to get our answer of 10, because this sheds more light on the general solution. It was 4 plus 3 plus 2 plus 1. So what about if we only had 4 teams in the group? And then again, you could jump back to your circular geoboard at this stage if you wanted, or you might just be able to visualise that the solution is going to be 3 plus 2 plus 1, or 6 games. And then if you extended the group size up to 6 teams, then it's going to be 5 plus 4 plus 3 plus 2 plus 1. So pupils at this point might be describing the pattern as however many teams you've got in the group, you start with a number 1 less than that and add up all the numbers down to 1. Now what we're actually looking at, of course, is triangle numbers here. Now, what if we had, say, 10 groups, 10 teams in the group? Or a ridiculous case where you had 100 teams in a group? Then how could we model a solution to that? And that's where Q's and air rods might come in handy. So here's a great example of where switching the manipulative can shed a bit of new light on the problem. So switching to Q's and air rods, here's the solution to the first problem. So with 5 teams, remember it was 4 plus 3 plus 2 plus 1. And crucially, you can see this triangle number forming. Now, the great thing about triangle numbers is that you can always make another copy of the triangle number and rotate it, and then slot them together to form a rectangle. Now, the dimensions of this rectangle, in this case, is 4 by 5. And you can see the width is 1 more than the height. So to work out its area, I'd do 4 times by 5, which is 20. But then recall that I made an exact copy of this, so I'd need to get rid of half of the rectangle. So I'd divide it by 2, which gives me my answer of 10. 10 games were played when there were 5 teams in the group. And you might be thinking, well, that's using a sledgehammer to crack a nut here. I could have just done 1 plus 2 plus 3 plus 4. And you're right. But the idea is that this structure can generalise now. So what if we went to 6 teams? Well, if I went to 6 teams, well, I'd need to add an extra 5 rod here, because now the solution would be 5 plus 4 plus 3 plus 2 plus 1. And if I make an exact copy of that and slot them together, you can see how my rectangle has grown. Now it's 5 times 6. So it's going to be 5 times 6, and then always I'm going to need to divide it by 2 because I only want half of the area which gives me my solution of 15 and so on. And the nice thing is, you can obviously generalize this to any size group. So if you had 100 teams in the group, well, your rectangle is going to be 99 times 100, divide by 2, and so on.